Why do mosquitoes always choose you? It's not just bad luck, and it's definitely not your imagination. Recent studies have uncovered something chilling. Mosquitoes can detect your presence from over 100 feet away, using the unique chemical signature your body releases. But here's what scientists won't say out loud. Some people's scent is so irresistibly visible to mosquitoes, it's as if they're marked, tracked, selected. And once chosen, it's almost impossible to go unnoticed. But why? And more importantly, what if they're not just hunting for blood? What if these tiny creatures are evolving with a purpose? In the next few minutes, you'll discover what's really attracting them and why that should terrify you, especially when you realize it might not be your blood they're after. Hit like, subscribe, and let's go. For most of us, mosquitoes are just an annoying part of summer, buzzing around your ears at night, leaving behind itchy welts, and somehow always targeting the same people. We've all heard theories. Maybe it's your blood type, your sweat, the color of your clothes. But those explanations only scratch the surface. In truth, the science of mosquito attraction is far more complex and far more disturbing. Right now, over 3,600 known mosquito species exist, and many of them have evolved to zero in on humans with terrifying precision. These aren't just mindless insects. They're equipped with sophisticated sensory systems, capable of detecting carbon dioxide, body heat, lactic acid, and even the bacteria living on your skin. What's more, some species have begun to specialize not just in hunting humans, but in choosing which humans to feed on. Across the globe, researchers are noticing patterns. Certain people are bitten dozens of times, while others, standing right next to them, are left untouched. Why? What invisible signal are we giving off? And if mosquitoes can read us so clearly, what else are they capable of detecting? In today's world of rapidly shifting climates and global travel, mosquito behavior isn't just a niche concern. It's a growing public health threat. With diseases like dengue, Zika, and malaria on the rise, understanding how and why mosquitoes choose their targets could mean the difference between life and death. And yet, there's something deeper happening here. Something science hasn't fully explained. Because as we dig into the data, we start to see strange, unsettling patterns that hint at something more than biology. Something that feels intentional. The story begins decades ago, not in a jungle or some secret lab, but in a quiet research facility in Florida. In the 1970s, entomologists noticed something strange. Two individuals standing side by side in a mosquito-infested area would often have drastically different outcomes. One would be swarmed, while the other remained untouched. It was more than coincidence. Over time, patterns emerged. Blood type O? Higher risk. More body heat? More bites. But then, things got weirder. In 2011, a team of researchers at the London School of Hygiene and Tropical Medicine discovered that mosquitoes could detect genetic differences in humans through the chemicals naturally emitted by our skin. Not just what we smell like, but who we are. And that changed everything. Suddenly, it wasn't just about scent, it was about identity. The implications were chilling. Certain people were being selected based on genetic markers. And in isolated regions, especially in parts of Africa and South America, field scientists began reporting that mosquito behavior was shifting. They were adapting faster than expected, avoiding traps, bypassing repellents, and feeding more aggressively on specific individuals. These weren't random changes. They looked strategic, as if something deeper was evolving, something more aware. And as genetic modification experiments ramped up, with mosquitoes being released to fight disease or reduce populations, new, unintended consequences began to surface. Some modified species didn't die off. They thrived, crossbred, mutated, and soon, entire regions reported rises in bite selectivity, with no clear explanation. So the question becomes, what exactly have we done? And what, or who, are mosquitoes truly learning to seek? Today, more than half of the world's population lives in areas where disease-carrying mosquitoes are common. Every year, over 700,000 people die from mosquito-borne illnesses, more than from any other animal on Earth. But numbers alone don't tell the full story. In cities like Miami, Rio de Janeiro, and even southern parts of Europe, local authorities have reported increases in mosquito aggressiveness and bite selectivity. You may think bug spray and nets are enough, But new field studies show some species are completely ignoring repellents they once avoided. In fact, recent lab tests in Singapore revealed mosquitoes learning to wait until the chemical potency fades before attacking. That's not instinct. That's behavioral adaptation. And it gets darker. Researchers at Johns Hopkins found that some mosquitoes are now responding to stress hormones like cortisol, meaning if you're anxious or afraid, they might detect you more easily. Let that sink in. Your fear could be calling them. Across war zones and refugee camps, outbreaks of dengue and chikungunya are emerging in new populations, not randomly, but with horrifying precision. And where outbreaks appear, they often return, stronger, smarter, as if the mosquitoes remember. Surveillance footage in Brazil even showed swarms avoiding human movement, as if calculating the best time to strike. Still think you're just unlucky? Think again. This isn't random. This is targeted. This is learned. And as the climate warms and mosquito habitats expand, the question is no longer if you'll be bitten, it's when. And by then, will it still just be about a bite? Here's the fact that changed everything. In 2022, a team at Rockefeller University discovered that mosquitoes can remember individual human scent profiles and even prefer certain ones after repeated exposure. In other words, they don't just smell you. They recognize you. And if they like what they find, they come back. But what truly stunned researchers was how they remember. Deep within the mosquito's brain, yes, they have one, is a learning circuit surprisingly similar to those found in mammals. This discovery shattered the idea that mosquitoes were simple creatures. No, they're not. They can associate your smell with a reward. They can learn, and they can pass that preference genetically. Let that sink in. If you've been bitten before, there's a chance nearby mosquitoes are already coded to find you again. And again, some scientists even hypothesize that, in areas with high mosquito density, humans could develop invisible scent-based hierarchies, where certain people are targeted more aggressively, not just because of biology, but because mosquitoes have collectively adapted to prefer them. Almost like a collective memory. Naturally, not everyone in the scientific community agrees. Some call it insect pseudoscience, while others warn we're underestimating what evolution can do when it's pressed by climate, overpopulation, and genetic interference. But the data is piling up, and with every new experiment, one thing becomes clearer. Mosquitoes are not just reacting. They're adapting to us, learning from us, selecting us. So now, what happens if the species we've always ignored suddenly knows us better than we know ourselves? Today, scientists around the world are racing to decode the full extent of mosquito intelligence, and what they're finding is both fascinating and unsettling. At the Max Planck Institute in Germany, researchers are using high-resolution neural imaging to map mosquito brains in real time, watching how their neurons light up in response to specific human scents. In Japan, AI-driven scent analyzers are being trained to simulate mosquito olfaction, not to fight them, but to understand why certain profiles are so attractive. The results are disturbing. Specific combinations of body odor compounds, like ammonia, carboxylic acids, and acetone, seem to trigger a hyperreceptive state in some mosquitoes, as if switching on a predator mode. Meanwhile, at MIT, engineers are working on genetically edited mosquitoes that can't carry diseases, or, more controversially, that can't reproduce. But attempts to release these gene-edited insects into the wild have sparked fierce debate. What if we don't fully understand what we're changing? What if we're only making them smarter or more selective? The truth is, despite all the progress, we're still chasing shadows. Mosquitoes continue to evolve rapidly, and our tools are always a few steps behind. Even the most advanced repellents, ultrasonic devices, and scent-blocking clothes fail under real-world conditions. And while we try to contain them, they're spreading into new territories, places where they've never lived before. Places like southern Canada, northern Europe. The world is warming, and they're moving with it. Faster, deeper, closer. And through it all, science is learning one hard truth. You don't need to be the most attractive, you just need to be recognizable. As research deepens, so do the theories. Some scientists believe we're on the verge of a breakthrough. that if we decode the full spectrum of mosquito-human interaction, we could eliminate deadly diseases for good. But others aren't so optimistic. A growing faction within the scientific community warns that our interventions, releasing genetically modified mosquitoes, altering ecosystems, manipulating scent signatures, may be triggering an evolutionary backlash. One we can't control. Whispers have started. Some believe mosquitoes are beginning to exhibit collective adaptation, not just isolated mutations, but coordinated behavioral shifts across continents. It sounds impossible until you look at the data. Species separated by oceans are evolving identical bite patterns, identical scent preferences, as if they're learning from one another. And here's where it gets darker. Independent researchers have raised concerns that global scent databases, used in biometric tech, fragrance development, even medical diagnostics, could one day be weaponized. What if mosquitoes were trained to target specific profiles, specific populations? It's a theory dismissed by governments, of course. But the patents exist. The studies are real. And history has taught us, progress always casts a shadow. Every attempt to fix nature has consequences. Every victory has a cost. So what if this isn't evolution, but reaction? What if nature is pushing back? One researcher put it bluntly, we taught them too much. Now they know how to find us, better than ever. So ask yourself, what happens when the world's deadliest creature becomes the one that chooses you on purpose? The shift wasn't instant, but it was undeniable. In regions where modified mosquitoes were released, local bite patterns changed drastically within months. People previously untouched suddenly became primary targets. Hospitals reported strange symptoms following bites, not always deadly, but persistent. Lingering fevers, altered sleep cycles, even neurological anomalies. Researchers first dismissed them as coincidence, until the patterns grew. Entire neighborhoods marked by clusters of identical reactions. Governments urged calm. It's under control, they said. But beneath the surface, quiet panic spread. Insurance companies in South America began denying claims related to mosquito-borne illnesses, citing unnatural risk exposure. In parts of Southeast Asia, schools shifted to nighttime hours to avoid peak mosquito swarms. Meanwhile, scientists faced a bitter truth. Their interventions may have created a new class of organism. Smarter, faster, selective. No longer a passive transmitter of disease, but an active vector of human vulnerability. Some began calling it the first human-engineered predator, not by design, but by consequence. And worse, it wasn't limited to one place. As the climate warmed, mosquitoes expanded north. Chicago, Berlin, Toronto. Bites rose. Resistance dropped. The line between pest and threat blurred. And humanity, the architect of the shift, stood unprepared. The balance had tipped. The invisible hunters we once swatted without thought now moved with purpose. And whether driven by evolution, adaptation, or the shadows of our own experiments, one fact became clear: we had changed them. But in doing so, we changed ourselves. So now the question isn't just how to stop them, it's how to survive in a world where we are no longer the dominant species. We stand at a crossroads, one we never truly saw coming. For decades, we viewed mosquitoes as a nuisance, a problem to be managed, a species to be modified. But in our attempts to control nature, we may have taught it to outgrow us. Faster evolution, learned behavior, selective memory. These are not traits of mindless insects. These are signals, warnings, reflections of our own interference. Now we face a choice. Do we double down on genetic control, surveillance, and eradication, risking further mutation and resistance? Or do we step back, accept that we've crossed a boundary, and begin working with nature instead of against it? Some scientists call for a global moratorium on mosquito engineering, citing the irreversible ecological shifts already taking place. Others argue it's too late, that the only path forward is through more advanced bioweaponry, smarter AI-led monitoring, and deeper DNA profiling. But at what cost? When the predator learns your scent, your biology, even your emotions, how much more of yourself are you willing to give away to survive? There is no reset button, only forward. We've reached a point where every decision carries weight far beyond the lab, beyond politics, beyond borders. We must ask ourselves, is this how new apex species are born? Not through brute strength, but through quiet adaptation, through exploiting what we fail to see. If so, then maybe the real question isn't whether we can outsmart mosquitoes, but whether we still deserve to be the ones in control. Because sometimes, the most dangerous predator is the one you accidentally helped evolve.